Page 279, question number 18. A mass attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. When the mass is released, it takes 0.3 seconds to reach a high point of 60 centimeters above the floor. It takes 1.8 seconds for the mass to reach the first low point of 40 centimeters above the floor. Sketch the graph of this sinusoidal function, and we'll also be determining the equation for the distance from the floor as a function of time. Let's start with the graph. We'll draw in our x and y axis here. So when I first read this question, I'd like to draw in the max and the min so I can figure out that d value. So when I reread this, I see that it reaches a high point of 60 centimeters. This isn't going to be to scale. And then we've got a minimum of 40. We'll put in the units. So that's our max along here, and this is our min along here. The midway point will be the median, so we can take the max plus the min and divide that by 2. So if we do that, or we can clearly, the midpoint you might be able to just recognize as 50. So our d value is going to be 50. I'm going to still label that down here because we'll use that in B. This also gives me the amplitude, the distance between here, so the amplitude is 10. Okay? Now let's figure out where our points need to be along here. It takes 0.3 seconds to reach a high point. So we need a maximum. So if time 0 is here, we're going to move over, and we'll say this is about 0.3. So this is going to be time in seconds along here. This was height in centimeters here. So our, what was that, a high point. So we put a high point, we're going to have a max there. Now we know we're going to have 4 points along here. Okay, we want to know how far apart the points are. Well, I only have 0.3 seconds to work with, but if I look at the question again, I have 1.8 seconds for the mass to reach the low point. So my low point right here is 1.8. Now this is not a full period. This distance right here is half the period. So from 0.3 to 1.8, 0.3 to 1.8 is half the period. Okay? So that's a time frame of 1.5 seconds. So we're going to times that by 2 to get 3. So our period is 3, which, since we're going to be using the equation, we may as well write our b value of 2 pi over the period. Okay, just to be a little more consistent, I like to know how far apart are these points, just so that we can kind of be accurate on our sketch. Even though this is a sketch, that's fine. We can put an arrowhead this way. We can put an arrow this way since it is continuing that way, at least to 0. If I want to look at how far apart the points are, rather than just estimating between here, I could take this distance and cut it in half. But if we go back to remembering how we sketch these graphs, we can also take our period, which is 3, and divide it into 4. So 3 divided by 4, so the 3/4 or 0.75 units apart. So if I take 0.3 and add 0.75 to that, that's going to give me 1.05. Add 0.75 would give me 1.8. 1.8 plus 0.75 gives me 2.55. Plus 0.75 gives me 3.3, etc. Let's look at completing B with the equation, because we've got most of this figured out already. So if we're putting in our values, so let's use D for distance from the floor. Our A value is 10. It's going to be easiest if we want to pick sine, cos. I can use cos right here. This is negative sine, negative cos, positive sine. I'm going to pick the easiest one and just pick my cos value. So we could use cos, put in our B value of 2 pi by 3. I'll use t for time, and if we're starting at a max here with that cos, like I said, t minus 0.3 plus 50. Now, you might be thinking, that's not the right answer. Where did we go wrong? Because the textbook did not have that written down. The textbook has an answer using plus 0.45, I believe it is, because they extended the graph. And if I take this graph and take 0.3 minus 0.75, I get to 0.5, and I believe they used then, I didn't sketch that very clearly, a sine wave. So that is also a correct answer. It's just harder to find that answer, so we want to go with what's the easiest to find. Last part would be for C. If I want to find the distance from the floor when the stopwatch reads 17.2 seconds, we're plugging 17.2 in for time. I'm going to use the equation that I first came up with here. So if we plug that into my equation for t, and for there you want to substitute this into your calculator, making sure that this is in radian mode, as your b value is in radian, and it works out to be 43.3 centimeters.